Hey everyone, this is a video intended to give you some essential ways of thinking about improper integrals and some tools to sort out whether things converge or diverge when we're given an improper integral. So what is an improper integral? It's when you've got a function and you're finding the area as that function goes out to infinity, somewhere out there in infinity land, or possibly you're finding the area that is trapped by a vertical asymptote. So our textbook calls this type 1 and this type 2. So you'll see you really need to pay attention to the boundaries, because you'll have some point A and it'll say out to infinity, or it'll be some point A to some other point B that's an asymptote. So you can be misled very easily by not paying attention to those boundaries. Okay, so that's one really important thing. Another is that this 1 over x is a hugely significant boundary. It leads us really to the discovery of E. It is an essential thing when we come to doing our sequences and series. But for now, just think about what it means to have a function that's 1 over x, or also think of it as y equals 1 over x. That graph looks like this. That's actually called a hyperbolic curve. We have this very simple point at 1, 1. And so if we're going to find the area of this part out to here, you can set up an integral. And when you do the integration, you realize that x to the minus 1, we can't do that reverse power rule. The integral for 1 over x is the ln of x. And when we have the ln of x, as x goes to infinity, the ln of x goes to infinity, but very, very slowly. And so that leads us to conclude that this is a divergent function when we have it as an improper integral going out to infinity. Now, as you notice, if we were to solve this and reframe this as x equals 1 over y, and in a sense flip this around and think of it as a function of the function is x in terms of y, then if we were to integrate that, we would be, in a sense, finding this area going this way as well, just by sort of turning it on its side and then flipping it over. Mathematically, it's the exact same thing if you think about it. When I go out to 2, I'd go up to 1/2. When I go out to 3, I'd go up to 1/3. If I flip this around, the same thing would be true. If I'm up here at 3, I'd be at 1/3 for the x. If I'm at 2, I'd be at 1/2 for the x. So mathematically, this is symmetrical, so we can conclude that this is our type 1 improper integral. If we look at the type 2 version of it, it is also divergent. So this one is divergent either way. So my point is that if we're slightly more than x to the first down below, if we have x to a slightly larger power, that this will converge when it's going out to infinity. That's the type 1. But it will diverge if it's written as from 0 to a. If we're summing up this area, because it's slightly larger, it will diverge when we're going towards that axis as the asymptote. Okay, conversely then, if x is below our boundary, that makes sense. If x is smaller, of course it diverges. But if it's going from 0 up to that vertical asymptote at 0, then it will converge. Okay, so the area here would converge if we're summing from in this case 0 to 1. We would have a convergent area under there. Okay, so once we understand that this boundary, this 1 over x is our boundary, we need to pay attention to the degree of x in the denominator. Anything that's bigger than 1 will converge. Anything that's less than 1 will diverge. All right, so our textbook has like 30 examples, and let's just go through and look at these. So here's a photocopy of our textbook so I can write on it. If we look at this, so here's the first one. Looking at those bounds, it's going out to infinity. Is this exponent bigger than 1? Well, that's 1.5, and yes, it is, so that one will converge, and you can do that as one of your homework problems. 6 is the same thing. It's going out to infinity. This exponent is 1/4, so x to the 1/4 power. Of course, in infinity, that 1 is going to be negligible, so this is essentially x to the 1/4, clearly less than 1, so this would diverge. Okay, so our reasoning is a little more than that. Sometimes we have to pay attention to which direction we're going in, but this is the same thing here, in that if our exponent here is to the 1/2, yes, as x gets larger and larger and larger, but negative, larger and larger, going to infinity, the mathematics is the same, that fractional exponent of 1/2 is less than 1, so this will diverge. Okay, well here what's going on? Well, if I were to FOIL this out, the lead coefficient would have a degree, or the lead term would have a degree of 4, and it might cancel with 1, but it's essentially x to the 3rd. 3 is bigger than 1, so this will converge. We're not going to worry about the 1 up there. If we have 4 x's down below, they'll cancel, essentially. Okay, so this is one that we'll come back to as an example. That's a classic example of one that will converge, and we can find a value. Okay, so exponentials, typically an exponential that goes like this, okay? Positive exponential, e to the x, this part of it, if we go to negative infinity, will converge. So if it's a negative x value, as this one is, even if it's 1/2, even if it's 1/10, even if it's negative 1/100th y, that will still converge, okay, if it goes out to infinity. So that's convergent. This one, okay, now what's happening here? You're going to negative infinity, so that's really this graph going in the wrong direction. So that's where you pay attention to those boundaries. If this was going from 1 to positive infinity, it would converge, but it's going the wrong way, so it diverges. Number 11, sine functions go up and down, up and down. If it's going out to infinity, that is going to diverge. That is not trapping a finite amount. 12, what's happening here? You're going from negative infinity to positive infinity. This is just a polynomial, so there's no way that that is going to trap something and decrease to 0 and converge. So that one is going to diverge. Also, in negative infinity to positive infinity, those typically what you do is you cut them somewhere and you do each half. If any 1/2 diverges, the whole thing is said to diverge. All right. So looking then at these, keep going, see if you can, like, pause the camera, whatever, go down and do each of these based on what I've discussed. See if you can do that. Unpause yourself, hopefully come back. Look at this one. This one, very cleverly going from negative infinity to positive infinity. And if you look at this type of function, the quick answer that on the AP exam, if you see that, hopefully you'd know to be like, oh, odd functions, they do that thing where whatever happens over here, the mirror image happens right there. If we're going from one extreme to the other, that would cancel out perfectly. We know not only that it converges, we can instantly see that it converges to 0. If you do the math and if you split it at 0 and do each half, you will get an actual value and they'll be exactly equal and opposite. You can try it. 14, this is an exponential going out to infinity. This is making it small and this is making it smaller, so this does converge. So you can check that one out. 15, here we've got an x basically canceling with an x squared, and 1 over x, that's our boundary. These things become insignificant. This one will diverge because of that 1 over x boundary. 16, here's cosine. That one is going to diverge for the same reason as the other. Just is going up and down, so we're not going to ever have it approach an asymptote, horizontal or vertical. 17, this one is going out to infinity. Again, the negative exponent gets small very, very quickly. Even if this is going to infinity, that's going to 0 much more quickly, being exponential, so that's convergent. This one here is going to negative infinity. So if we're going in the other direction, it's a lot like that graph where it's going like this, and I'm going in that direction. So yes, exponentials decrease quickly enough that it will be convergent. 19, okay, so if 1 over x doesn't converge. It diverges. Something that's making it bigger is definitely not going to make it converge. So this is divergent. It's going out to infinity. Here's a negative to positive infinity. Again, if you look really closely, because that's x to the even power, this is going to be an odd function because x will go from positive to negative. So for the same reason, this converges and it's equal to 0.